Hello there, this is Chica Paris bringing you a Flappy Bird tutorial, but it looks and feels exactly like Flappy Bird. So I've noticed when I looked online on YouTube, people have been making Flappy Bird tutorials. It's not a new game, it's been there for 9 years. The thing is that none of those videos were able to faithfully recreate Flappy Bird. And so here we are, we see it looks like Flappy Bird, but is it? We press this button right here and we see the usual get ready, tap the button. Everything so far looks exactly like Flappy Bird, and we start moving. Feels like Flappy Bird. We could hear the sound effects. It works. We can get high score. Let's see how far we can go. Okay, I was not real good there, but we have the game over, the medal, the blings and everything. This best score over there, and if we press this button here, we start over again. The bird actually changes colors. If we die right here, press the button. It's still nighttime, but now the bird's still red. Let's try to see if we can make it morning. Oh, there's no morning, is there? Where's the morning? Hey! Let me try. Oh, there you go. There we go. So everything works exactly the way it works. It looks and feels exactly like Flappy Bird. So we're going to make exactly this thing, and I'm going to teach you exactly how. So, let's begin. So for this tutorial, I'll be using Gamemaker Studio 2. If you're using Unity, Godot, or any other game engine, I hope you still can follow, as I won't be using any functions exclusive to only Gamemaker Studio 2. Now, to make things easier, I have already downloaded, placed all the sprites and sound effects into the game. Now, if you want to have all of these already convenient for you, you can look on the description down below, and I have created a project file that will have all of these sprites already cut for you, so you can just use it straight away. Now, this thing also comes with its own room and its own object bird. Just one object bird. Now, this object bird has nothing in it except for the sprite, and this object room basically just has that object bird right in the middle and background. So if we are going to be running this game, we would see that there's just nothing but just the Flappy Bird right there in the middle and the background. You can't do anything, you can't control the Flappy Bird. So our first task is to add gravity. So we'll go to object bird, and as you could see, nothing is programmed just yet. So the way we're going to do gravity is that every frame we are going to be moving the bird downward. So how do we do that? Basically, the coordinates of the bird is dictated by the variable x and y. Now, the bird will always be in the same x coordinate, but it will not be in the same y coordinate. So to do that, we're just going to say add event, and then we're going to go to step, make a step event here. Now, the step event, basically, this is going to be running every frame. So if we're going to say y is going to be equals to or plus equals to 2, what's going to happen is that the bird is going to start going downwards 2 pixels every frame. So I believe some of you might have missed the bird falling down. If you did miss it, what we can do is that we're going to be adding this command here, this code. Basically, every time we press the button Q on the keyboard, it's going to restart the game. Now, this is just for debugging purposes, but it really makes it easier for us to restart the game at any time when we already compile the game. So we could see when we press Q, the bird goes back to its original position and starts falling down. So here we could see clearly that our y plus equals 2, which makes the bird fall down, is working properly. Now, the problem about this gravity is that it doesn't feel natural. The bird is falling down at a constant rate. If we know how gravity works, it's an acceleration. What's supposed to happen is that in the beginning, the bird will start falling slowly, but as time goes on, the bird will start going faster and faster and faster. To program this gravity, we are going to be making a new variable. Now, this variable will be set on the create event. So what is this create event? This create event happens when the bird is created, which happens at the start of the game. So this only happens once. So we're going to be setting this variable. We're going to be calling it s speed or v speed, and this will be set to 0 in the beginning. Now we go back to the step here, and we're going to say that y is plus equals to v speed, vspd. If we run the game, since it's set to 0, the bird should be staying in place. If we were to set this v speed to, let's say 2, like it was before, it's going to start falling down like before, as you can see. But we don't want it to be constant. Remember, acceleration has varying speed. So this v speed should be varying. So what's going to happen? So we're going to be setting this back to 0, we're going to be adding another variable, and we're going to be calling this g acceleration, and we're going to be setting this value to 0.3. So what this is going to do is that we are going to be using this g acceleration to increase our VSPD over time per frame. So we'll go back to step event, and just like this y variable, we're just going to be copying the same format, but instead of y, we're going to say v speed is going to be plus equals to g acceleration. So this v speed is going to be increasing by 0.3 every frame, and then this y is going to be increasing by v speed every frame. So this thing is increasing and this thing is increasing. This creates an acceleration. So if we're going to be running the game, we'd see that the bird is now starts falling slower, and then it starts going faster and faster and faster, just as we programmed it to be. Now you might be wondering, why are we going through the hassles of creating all of these numbers here when we could actually just, let's just comment this guy out, and let's just comment this guy out, and instead of using those, we just use this thing called gravity, and we just set it. Let's say if we set gravity to 0, nothing's going to happen, obviously, because gravity is 0. But if we set gravity to 0.3, just as the same as this value here, and what's going to happen is you will see that the bird is falling down exactly the way it did earlier, but with less lines. Now, despite that, I would still prefer you guys to not use this gravity built-in variable, because you have less control over what's going on. And later on, while we're making Flappy Bird, we would want a lot of control of every single movement of the Flappy Bird. So we don't want to do that. Instead, we just want to do it the old-fashioned way of setting each and every variable just the way it is. This is actually basically what happens in the background with the gravity. We're just doing it manually. Now, we may have programmed the gravity, but there's still just one problem. It's just going too fast. In the beginning, it's just right. But over time, it just keeps on increasing its acceleration to the point that it's just going too fast. Now, to prevent this, we're going to be adding this thing called terminal velocity. So, to do that, we're going to be creating another variable. And this is going to be called term v, and we're just going to be setting this to 2. So, what this means is that we're going to be capping this VSPD to 2 when it reaches the speed of 2. So, instead of doing it this way, we're going to be using the old just equal sign, and then we're just going to say VSPD is going to be plus g acceleration. So this is basically the equivalent of saying plus equals g acceleration. Now, once we do it this way, we're going to be using a function called minimum. And then we're going to be putting this here inside the function minimum. And then we're going to be putting the v term, or term v. So what this does is it's going to take the minimum of this value or this value, whichever is smaller. So if term v is smaller, it's going to set v speed to term v. If this v speed plus g acceleration is smaller than term v, it's going to be setting this v speed to this value here. So let's say that v speed is 0 and g acceleration is 0.3. So this one, if you add them together, is going to be 0.3. This one's of 0.3 is definitely smaller than 2. So v speed will now be set to 0.3. But let's say v speed is already 2. So 2 plus 0.3 of the g acceleration, that's going to be 2.3. 2.3 is larger than the term v, which is 2. Therefore, the minimum value will now be term v. And so v speed will now be set to term v, which is 2. And so it will never, basically what this function does is that it will never go beyond 2. It will cap at 2. Now that we have done this, let's just see it in action. Let's see how it works. So you'll see that it's accelerating. The gravity makes it go faster in the beginning, but it stops accelerating once it reaches 2. Now, I feel like 2 is such a very small value, and I think that the acceleration is a little bit too fast. So we're just going to be changing that, and we go back to the create event, and we just simply have to just like say change the g acceleration to 0.2 and the terminal velocity to 4. And if we were going to run the game, we would see that things have changed a little bit. So now it feels more tuned. You could feel that gravity pulling it down better than last time. So this is the good thing about having your variables set like so. This is good practice. So you can just change these, tweak these values, so then you can get that right value. This is important so then the game feels correct. I've seen many YouTube tutorials on Flappy Bird, and their values for these things, the gravity and the terminal velocity, it's just not right. And because it's not right, it just feels wrong. If your game doesn't feel right, even if you have all the mechanics, because the values are not placed correctly, it just won't feel the same, it just won't feel good. So now that we have made gravity, we're going to making the bird jump. Now this is actually a lot simpler than gravity itself. All you have to say is that when we tap on the screen, the Flappy Bird's velocity will change to go upwards. And then gravity will just bring it downwards naturally. All we have to do is just add this variable is jumping. This is a local variable as dictated with this var symbol here. This is local to only this step event, which means that you cannot access this variable in the create function. And then we're going to be equating this to this function here. This function just tells us whether we are tapping on the screen. If we are pressing the left button, this will return true. If we're not, this will return false. Now, the reason why we're making this a local variable is because this is jumping will always change per step, which means we don't have to store the previous value of is jumping, unlike, let's say, VSPD or Y, which actually tries to look back at the previous value of itself. Using this is jumping variable, we're going to be having this if statement called if is jumping, then we're going to set the VSPD to -3. Now, -3 means it's going upwards at 3 pixels per frame. And then gravity, this will change over time and it'll bring it back going downwards. If we just press F5 or run the game, we would see that when we press on the screen, the bird is already flapping. This is exactly what we want. Now, one reason why we place it in this is jumping button here is that we can actually add more functions to this is jumping. What are those? Let's say we want to make it that if we are to press the space button in our keyboard, we're going to be going upwards as well. Now, how do we do that? Well, all we have to do is just say is jumping is going to be equals to keyboard press VK space. Let me try to make this bigger here. We could say that is jumping is equal to keyboard press space or mouse press button space. Now we just usually put it inside a parentheses just to make it clearer that we are doing this or that. So if we are to play the game, now we can't really see it, but this is my hand, it's going to be pressing the space button and we are going upwards. Or if we click on the screen, we are also going upwards. That is the benefit of having your variable placed in this is jumping variable here. We could always just get this thing here, this entire part, and just put it here in this if statement, and that will also work. However, that's not very organized and that's not very good practice. So it's better to put things here to have more control. So in case we want to be accessing this is jumping in another if statement, we don't have to do all of these again. We just access this guy here. Now, there's another problem that we're going to be experiencing, and that is we can jump all the way up. We can just keep on jumping and we just can go out of the screen, out of bounds. So we don't want that. We want it in a way that we can only jump when the bird is still on the screen. So to do that, we're going to again use this is jumping to tell us that we have to be on the screen. So we just add this new condition that we say and y is greater than 0. Now for those who I forgot to explain, this means or and this one means and. Or means either this or this has to be true for this entire part here to be true, whereas the and, it has to be both this and this condition to be true. If one of them is false, this entire thing will become false. Now, the reason why we're saying y is greater than 0 is because when the bird's y goes off screen or goes too high up, that means that its y is already negative. Now, to explain this further, if we go to the rooms, we could see the coordinates are somewhere down here where my mouse is. When I put my mouse somewhere up here, that the coordinate, the y coordinate, is somewhere near 0. And then if I put it above this game, it's going to be negative. When I put it below, it's going to be a positive number. So when we say that y is greater than 0, it means that we are somewhere here below this upper edge. Now, one thing to take note is that depending on the sprite of the object, the origin of that object or the point of reference depends on what we set the sprite to be. So here in the object bird, if we go to edit sprite, we would see that its origin point is somewhere in the middle, as it says here, middle center. Sometimes by default, it'll be in the top left, which is over here. But for this bird, we set it here to the middle center. So we could actually check out the sprites here. Not all the sprites are in the middle center. Some of them are actually in a different position. If we go to the room and we click on the bird, but before we do that, we go to this layers here, bird, then we click on the bird, we would see that the X position and Y position is 44 and to 8. When the bird, if we move this upwards all the way up here, we would see that when the Y is equal to 0, the bird is actually halfway here. So if we actually want the bird not to jump when it's actually down here, we actually have to set the Y to 8 instead of 0. So we'll just press Ctrl Z just to bring it back to the middle, and then we go into workspace, and then instead of Y is greater than 0, we change this Y is greater than 8. That way, once the bird touches this upper line here, the upper edge, it's not going to jump anymore. It's not going to register jumping. So even if I'm spamming the space key, once I go off screen, the bird won't jump. It will only jump when it's on the screen, when it's below this edge. Oh, and before I forget, instead of setting VSPT to -3 as so directly, we could actually set this to a variable. So let's say we call this jump speed, jump SPD, and then in the create event, we put here that jump SPD is now going to be equals to -3. This is good practice. So then we can just adjust the jump speed here, or the terminal velocity here, instead of adjusting it here in the step event where it's more messy. Another method of doing this, which you can do in Gamemaker Studio 2, is that instead of putting it in the create event, we can actually put it in variable definitions. You just click here in var definitions, add VSPD, and we can set it to 0, the G acceleration, which you set it to 0.2, the term V, which we can set it for, the jump speed, which we can set to -3. And then we can remove everything here in the create event, and everything is just working exactly the way it is. But all the variables are in the variable definitions. So there are many ways to implement the ground. One way is to have an object ground that will be placed here, and then just like the bird falling down, at every step it's going to be moving backwards at a -x direction. And then once this object ground is in this position, we'll spawn another object ground that will fill in this gap here, and then this guy will continue moving towards the left, and then this one will also move towards the left. Now the problem with this technique is that we will just keep on spawning more and more grounds as we do this, and then if you just do it another time, we can spawn another ground as it goes to the other side. And doing this method, it's going to start lagging the game, as there will be so many grounds. So one way to solve that is by simply deleting the grounds that go off screen. So this one is already off screen, so we can delete that. This one is still not off screen, but once it goes off screen like so, that's when it gets deleted, and then we create another ground that goes to this side here, and so on and so forth. This is one method, but again, this is still not the best method. We can actually do this with just one ground. How do you do that? Well, if you notice, this ground here, when we put it here at this edge, there is this little tiny precision that's actually jutting out. Now, when I got the sprite, it was already looking at this, and I was wondering, why is it like so? There's actually a reason why. You see, when we move, if we look here first, you see that there's this green arrow pointing towards the upper left corner. If we move this ground all the way to the end here, and we were to look back at this corner here, it looks exactly the same as it was in the beginning, which is here. There's this green triangle here, and then here, there's another green triangle as well. So once it moves this direction, we can immediately shift it back, and it will look like it's a seamless transition. So when it goes to this position, we push it back immediately. So that's the better way of doing things. But there's an even smarter way, which is not even to have a separate object for the ground, but we can actually draw it using the object bird. Now before we can draw the ground, we have to take note of its origin, just like we did with the bird. So we go to the sprite ground, and we see that the origin is located at the bottom left, which is at this position here. Which means that if we want to draw it in this room, let's say we draw this, we want to be putting it in this lower left corner, which is at, if we go, it's at 0 to 156. Now we're going to delete this one because it's not what we want to put in it. We want to be drawing it using the bird. So we go to object bird, and then we add a new event, and this event will be called draw, like so. And here in the draw, we are going to be saying draw sprite, and we can see here the functions. We can just press enter here, and then there's some tooltips. If you don't know how to use this draw sprite, you could see there's sprite, sub image, XY. So the sprite will be called SPR ground, which is the same as this one here, and then we put a comma. Sub image. Now sub image is, let me demonstrate it here with this blue bird. The sub image is basically for those with animation, sprites with animations. So we go to edit image here. We could see that this is sub image 0, sub image 1, 2, and 3. We start with index 0. So here this bird has 4 sub images, whereas in the sprite ground we only have 1 sub image. So going back to the object bird where we're drawing, we're going to be saying that the sub image will be is equal to 0, which is the first sub image and the only sub image of sprite ground. Now for the x and y, like we noted before, x will be 0 and the y will be equal to 256. This again is the lower left corner of the game. If we were to run this, we would notice that the bird has disappeared, but the ground is now there. The reason why is because when we use this draw event, the normal default drawing of the sprite bird has been overwritten. So now it's just only drawing the ground. So what we're going to do, we're going to be saying draw self. So draw self will just draw everything that it used to draw before, but now here on the draw event. And so when we run this game, we'd see that the bird is now there. The thing is that now the ground is not yet moving. So how do we move the ground? We are going to be adjusting the x coordinate. So just like we did with the y, where we adding it to VSPD, we're going to be now adding something to the x coordinate for the ground. But instead of adding, we're going to be going negative because we want to go and make it go to the left. So we're just going to be adding a new variable definition, and we're going to be calling this ground x, and we're going to be setting it to 0. And then here in the step event, we're going to be saying that ground x is going to be equals or negative equals to, let's say, 1. And then we go to the draw event, and then we set here the x will be now ground x as so. So when we run the game, the ground is now moving towards the left, but it's not yet spawning backwards. So what we're going to do is we're going to do what we said earlier. Once it moves to the end, which is how much? So once the ground moves to this position, which when we click on the screen, it says here that the x is now negative 24. That is when it will be pushed back to the start. So we're going to say that ground x is negative equals to 1. And then when we say that if a ground x is less than or equals to negative 24, that is when we are going to be saying that ground x is going to be equals again to 0. So we're going to restart the ground x position. And so now that we have done this, we would see that the ground is seamlessly moving towards the left. And now the bird looks like it's going forward. Now that we have implemented the ground, we want to make sure that once the bird touches the ground, it will die. So we want to know at what position does the bird need to go until it will touch the ground. So we can do that by going to this room, and then we can just put a temporary ground here, and we can drag this bird down and see that once it's at this position, it's at y equals 196. So now that we've stored that, we're just going to remove everything and put it back to normal. And then we're going to be saying if y is going to be greater than or equals to 196, then we're going to just keep the y equals to 196. So if you run the game, once the bird hits the bottom, it will just stay there. But we still can move upwards even at this position. We want to make it that once it's down in the ground, it died and it cannot move anymore. And also that the animation has stopped for both the bird and the ground. So the best way to implement this is through state machines. Basically, we are in the main state, the main game loop of Flappy Bird. We want to go from the main state to the dead state, where in the dead state, we can't do anything. We can't move, the ground's not moving, everything is dead. So what we're going to do is that we're going to grab everything here and we're going to be putting it in its own function. I'll tell you why later. So we have a function and we're going to call this main state. Here in this main state, we're going to be grabbing everything that's going to work in main state and put it inside. To run this, we have to say script execute, and we're going to be putting the main state here. This main state, we're going to be putting it right inside here. So if you run the game, it should go exactly as it did before. Now, we want to be changing this main state to dead state. So to do that, we're going to have to make this a variable state. And then here in the create, we're going to say that state is going to be equals to main state. And then later on, we're going to be changing this state to dead state. But if we're going to run this, for some reason, we have this error that it just doesn't want to work. And the reason is because it doesn't know what main state is. It's in the step function, but it's not yet declared yet in the create. So what we can do is that we can grab all of this and put this in the create. We put this here in the create, and now it should work. Now, we want to be moving this state to the dead state. So, once we reach the ground, we're going to be saying that state is going to be equals to dead state. But we haven't made dead state yet. So, we're going to be making another function. And in this dead state, we're just going to do nothing. And then we're just going to put this above here actually. So then it knows that this dead state actually exists. So if you run this, now when we reach the dead state, we are doing nothing. But the bird is still flapping. So we have to fix that. To do that, we have to go to here in this state. Once we transition to the dead state, we're going to be saying that image speed is going to be equal to 0. What this does is that it turns off the animation of the bird, as so. But then, when you fall down, the bird is now having its wings upward, which just doesn't really look that natural. So, what we're going to do is that we're going to bring it back to the original sub-image. So we're going to say image index is going to be equals to 0. That way, it will bring it back to the original Flappy Bird image, as so. I was checking the video clips and I've noticed that whenever you see the game running, it's already in the dead state. So I'm just going to show you now that I'm restarting the game and now we are actually flapping, and then once we hit the ground, we are now in the dead state, and then if I restart the game, we're now back to the main state. So now that we've made the bird and the ground, let's ramp up the difficulty and let's make the pipe. To understand what we're going to do, let's go to the room and drag a temporary pipe. So we're going to make the pipe step by step, so then we don't get too overwhelmed. The first thing we're going to do is just we're going to be spawning this one single pipe outside of the room on the right side, and then make it travel to the left side until it goes outside the room again. And then once it's here, we want to be transferring it back to the start. So just like the ground, we are going to be drawing this pipe instead of making a new object. So we need to take note of the position of the pipe that we want to be drawing. So let's say we want to be drawing a pipe at this position here, and it's going to be at x equals 160 and y is equal to 152. So we go to the workspace and then we go to the draw event, and we're just going to be copying and pasting this draw sprite, and then instead of SPR ground, we're going to say SPR pipe. And then this 256, we're going to be changing this to 152 as we have seen here. And then for the X, now remember that this X is going to be changing as we move along, but we want it to start at 160. So we're going to be creating a new variable. Now I actually suggest that we create a new variable outside here instead of here because it's going to be changing. And saying that, I actually suggest that we actually grab this ground X as well and put it here. The reason is because we want to be keeping these variable definitions only to the constant values that we're going to be changing, whereas those that will be modified throughout the game will be here in this create event. So let's just bring back ground X here. This VSPD is also not a constant, so we're going to be putting here VSPD is going to be equal to 0 as well. I'm just going to be removing this. And then we're just going to be keeping these three because these ones are constant. So going back, we're going to be making a new variable called pipe X. And we're going to be saying that this is going to be equals to 160. And then in the draw event, we're just going to be putting pipe X here. And then in the create event here in the main state, in just like the ground X, we are going to be adding a new variable called pipe X. And it's going to be equal to negative equals 1. And then when it reaches the other side, we're going to be doing the same thing. So we're just going to be doing this. So just copy and paste for ground X, but we do it for pipe X. Let's change these values here. And then instead of negative 24, let's go back to the room where we want to change it. Let's say it's over here. We want to change it when X is equal to negative 16. So put here negative 16. and then it should go back to the original position, which was 160. There we go. So if we run the game, it should look like there's a pipe. And then once it goes out of the room, there's a pipe again. And then there's the pipe again. In the original Flappy Bird, there are more pipes that appear in the room. So we need to be making more of these pipes. We need to be drawing more. And I've noticed that the pipes in the actual Flappy Bird are spaced out 80 pixels away from each other. And there will be at least 3 rows of pipes seen in the game at one point in time. Usually there are only 2, but there's a certain point where there are actually 3. So we are going to be creating 3 pipes, and they're all going to be doing this thing right here. First things first is that we're going to be making an array of pipe x, because we're not going to just have one pipe x value, but 3 pipe x values. To do that, we're going to be saying for var I is equal to 2, and then I should be greater than or equals to 0, and then I minus minus. Now, if you're familiar with for loops, usually we're going in an ascending order, but this time we're going in descending order because it's better to initialize the last array in Gamemaker Studio. That's just good practice in Gamemaker Studio. So we're going to just put in pipe x, and then we're going to be making this an array, and then we're going to be making this pipe xi should be equals to a certain value. Let's say it's going to be equals to 300, and we're going to say plus I times 80. So what does this do? So in the beginning, we're going to start with I equals 2, and then the next loop, it's going to decrement to I equals 1, and then decrement again to I equals 0. Then when I is equal to -1, it's not going to fulfill this condition, which is I greater than or equal to 0. So that's when the for loop will end. So in total, it's going to do it 3 times with I equals 2, 1, and 0. So when I is equal to 2, this I here is going to be 2, this I here is going to be 2. So pipe x2 is equals to 300 plus 2 times 80, which is 460. When I is equals to 1, this will be pipe x1 is equal to 300 plus 1 times 80, which is 380. And then when pipe x is equal to 0, this will be pipe x0 plus 300 plus 0 times 80, which is 300. So we get pipes that are positioned at 300, 380, and 460. Now, aside from this for loop, we also have to make another for loop to handle this pipe x here. So we'll make the other for loop here for var I is going to be equal to 0. I should be less than 3i plus plus. Now this for loop is the standard incrementing for loop from 0 to 3 or from 0 to 2. And then we're just going to be grabbing this guy here and put it inside this for loop, as you can see. And then instead of just pipe x, we're going to be putting pipe xi, and pipe xi, like so. When pipe xi is less than or equal to -16, we don't want it to just bring it back to 160. That was the old value. We want to be moving the pipe 80 pixels behind the furthest pipe from the right. So what pipe is that exactly? Well, if pipe 0 is the one to the left, and that's what we're going to be pushing back to the start, that means the last pipe is pipe 2. If pipe 1 is the one that's transitioning to the right, then pipe 0 will be the one at the back. And if it's pipe 2, then it'll be pipe 1 at the back. We could use a bunch of if statements to handle this, or we could actually take note of a certain pattern using modulo. So we could say pipe xi is going to be equals to pipe xi plus 2 modulo 3, then plus 80. So what does this do? Well, basically, if I is equal to 0, plus 2, that will be 2, modulo 3, that will be 2. If it's 1, that will be 1, plus 2, that will be 3, modulo 3, that will be 0. If I is equal to 2, that will be 2 plus 2, that will be 4, modulo 3, that will be 1. So we were able to follow the exact same logic, but just using one liner. Now, we're just going to be copying this for loop over here, and we're going to go to the draw function, and we're going to be drawing this pipe x 3 times. So we're going to be using that copied for loop. So put that for loop here, and put the bracket, and then we're going to get the draw sprite and put it here, and then just pipe x, we're going to say pipe x I. Now the part we've been waiting for, let us start the game and see how it looks like. So first, there's no pipes because we set the pipe to 300, and then once the pipes appear, it will just keep on repeating itself over and over again. You could see that now they're coming more frequently because we've added 3 pipes instead of just 1. Now, the reason why we actually set the first pipe to 300 is because we want that little delay in the beginning. So now what we want to do is that we want to make the pipes come in varied heights. And then we also want to be creating the upper pipe on top of the lower pipe as well. So we are going to be first drawing the second pipe on top. To do that, we're just going to be copying this thing, draw sprite, but instead of just draw sprite, we're going to add an extension. And then what this extension draw sprite does is that it's going to be adding extra features. So if we go and look down here, we'll see that there's sprite, subimage, and then there's X and Y. And then there'll be extra parameters. The first one will be the X scale, which will be set to 1. The next one is the Y scale, which is set to -1. Then the rotation will be set to 0. The color will be set to C white. And then the last one is the alpha, which will be set to 1. So what does this mean? X scale will be set to 1, which means it's scaled 100%. And then the Y scale will be set to -100%, which means it's going to be flipped vertically. And then for the rotation, we don't want to rotate anything, so it's 0. C white is the default color. If we say C red, it's going to make the pipe look reddish. And then alpha is 1, meaning that it's going to be fully opaque. So if we run the game, we would see that the pipe will be right on top of the lower pipe, and we'll make a pillar like so. Now, why is it drawing this way? Well, that is because of the origin point that was set for the pipe. If we look at the sprites and we go to the object, the SPR pipe, we would know that the origin point is at the top center, which means that if we were to flip this, it will flip it at the origin point, which is at the top center. If we were to set this, for example, to the middle center, we would see that it's now going to be rotating at a different position, which is at the middle center, and it'll look something like this. We don't want this. What we want is that we want to put it at the top center, and then we want to be adding a gap so then the bird can go through it. We'll go back to the object bird, and then here we're going to be adding a gap. So instead of just pipe, instead of just 152, we're going to be adding a value which is going to be minus, let's say 64. So if we're going to look at it, we would see that now there's a gap for the bird to enter, which is very nice. Now, if you compare this to the original game, you would notice that the gap in between the pipes is a little bit smaller than what we have set it to be. So I don't think it's 64, and I believe it's actually 48. And then we would also notice that the pipes are actually drawn behind the ground, not in front of the ground. So a simple way to fix that is just grab this for loop and bring it right above the ground draw, and then we just run the game and see how it looks like. You would see that the pipes are now drawn behind, and the gap is just a little bit smaller, but enough for the bird to go through. Now let's make the pipe's height randomized. So to do that, we go to the create, and instead of just the pipe X here, we're also going to be setting a new variable called pipe Y. And we're going to be setting this to a random value from 0. So basically what this random value does is that it's going to set a value from 0 to the X that you set it to be. So what should the range of our random values be? Let's go to the room and check it out by doing some trial and error. So we're putting the ground here as well, and then we'll be using this pipe and another pipe. So we're going to copy and paste this pipe, and we're just going to make this scale -1 to flip it. Now if it's 0, our pipe will be looking something like this. Our pipe will be right here, which we don't want. So we want to make an offset. How much is that offset be? Well, let's say if our pipe is at 80, this pipe here should be 1, 2, 3, 4, 5, 6. This will be around 48. It will look something like this. Now, if I recall in Flappy Bird, it actually never really reaches this high. It does reach around this high. So we're going to be setting our pipe to 96. The offset will be starting here at 96, and then the lowest point will be somewhere here. I recall that it's going to be at 176. So from 96 to 176. So 96 minus 176, that will be 80. So we go back to object bird, and we're going to be putting here random 80 plus 96. And then we want this to be randomized as it gets respawned at the bottom. So we're going to be copying this guy here, and once it goes to the other side, we're going to be respawning a new random. And then this pipe Y, don't forget that this is going to be drawn here. Instead of just 152, we're going to be setting this to pipe Y I. And then don't forget to remove all these stuff here, because it's going to ruin the game when you run it. And also don't forget to set this pipe Y to this value here as well. And if you run the game, it should look exactly as it looks like in Flappy Bird. So we have pipe here, and then we have a random pipe down there, and another random pipe here, and another random pipe there. Currently in our game, we can actually go through the pipes, and also the bird is going behind the pipes. You actually want it to be above the pipes. And we want it that if the bird hits the pipes, it's going to die, just like in Flappy Bird. So we're going to be adding some collisions. So first we do the easy one, which is to transfer again this for loop and put it behind this draw self. So then it will draw the bird after it draws the pipes. And then we're going to be adding the collisions. Now this is the hard part because we actually are going to do this the mathematical way. So we're going to be grabbing our pipe here, and we're just going to be making this bird stay in this position, and we're trying to see exactly when will the pipe hit the bird. So if you put the pipe right here, which is very close to the bird, this means you could see that the bird's beak already hit the pipe, and the X positions, it's at 64. So we'll try to recall that 64, and then if we bring the pipe to the other side, we would see that the X is now 24. So we have 64 and we have 24. Now we want to make some leeway, so we're going to make this 25, and we're going to make this 63. Now for the Y collision, this is a bit tricky because the bird's Y position also changes. So we'll be basing it off from the bird itself. So we're going to be using the sprite to tell us exactly its bounding box. So we see here that the width is 17 and the height is 12. We're just going to be looking at height, which is 12, which means that there's 6 pixels up here and 6 pixels below. If we go back to the room, if the pipe is right, let's say it's down here, so the Y position is some random Y position, and the bird is 6 pixels above the pipe, then it's fine. But if it's less than 6 pixels above the pipe, it will be touching the pipe. And then we also have to take note of the pipe above it, which will be right here. And this one is 48 pixels above this pipe here. So it will be 48. But remember that this pixel here, there's a 6 pixels above the origin point of the bird. So that'll be 48 minus 6. That'll be 42. So if the bird goes 42 pixels above this pipe here, it will touch the top pipe. Now again, we're going to be adding some leeway because we want to add a little bit room for movement. So we're not going to making it 6 pixels. We're going to make it 5 pixels. So that will be minus 5 above this pixel here and plus 43 to hit this pipe here. So let's just delete these guys here, and we go to the object bird. Now we go to the create event, and here we're going to be killing the bird just like it does when it touches the ground, which is here in this dead state. So we're going to put the if statement over here, and now this is going to be a very long if statement, but basically we can split this into 2 parts: the X coordinate check and the Y coordinate check. For the X coordinate check, we're trying to see whether or not the bird can hit the pipes in the X axis. So that's when the pipe X is greater than 25 and when the pipe Y is less than 63. This is the position when the bird's somewhere in the middle of the pipes. And then this Y coordinate check checks if the bird hits it from the top or bottom. So if Y plus 5, so this is the bird's Y, plus 5, so 5 pixels below the bird, will it touch the bottom pipe? Or Y minus 5, 5 pixels above the bird, will it touch the pipe above it? So that's pipe Y minus 48. Now we can actually move this minus 5 to the other side, transpose this, and change this to 43, so there will be less calculations. And then we're going to be setting the state to dead state, so then once we hit the pipe, it's just going to die. So if we run the game, we would see that if we are going to go through the pipes, everything works. But if we touch the pipe, let's say we touch the pipe from the top, it's going to die. Now we haven't yet created the falling phase, but we'll do that later. Now if we touch the bottom pipe, it also dies. And if we touch the side of the pipe, it also dies. We want to be fixing the part where the bird dies, it just stays there. We want it to fall down to the ground. Now to do that, we are going to be adding gravity in its dead state. Right now, the dead state basically does nothing. That's why everything stops. We also want to be adding gravity just as it does on the main state. So the gravity, if you recall, happens in this position here. So we're going to be grabbing this and we're going to cut this, and we are going to be putting it in another function called add grav. So here in add grav, this is the function that will give us gravity. So we're just going to be returning us back here, but in the function, and we're also going to be putting this add grav here as well. We'd see that once we die, unfortunately, I realized we can't have these functions in the create event. We actually have to put this on the script, an extra script. So we have to make a script here. So you just say create script, and we just call this src bird scripts. And then we go back to object bird, and we just copy all these functions here and paste this in the bird script. And now it should work. So everything looks exactly the same. Everything's working. But then once we die, we actually fall down and gravity hits us. But then you'll see that we fall and we actually don't drop to the ground. We actually fall beyond the ground. So we're just going to fix that very easy. We're going to be saying this statement here as well. So we're going to be adding it here to the add gravity. Now it's okay if we say the state is equal to dead state. When we're already in dead state, it just makes us get looped back to the dead state. Although I think that's actually not a very good thing to do. So we're just going to be copying this again and then pasting it here, and we're just going to remove that and remove this. So once it's y equals greater than equals to 196, we go to dead state, and here we just remove the dead state because we don't want to repeat that dead state function. Now we start the game again, and once we're running, once we die, we see that we stuck to the ground right there. Let's do it again, test it again just to see if it's working. So if we touch the ground here, it works again. So our Flappy Bird is almost playable. We just have to add a scoring system. So to do that, we just go back to object bird, and then in the create, we're just going to be creating a new variable called PTS, which will be points. And we're going to be setting this to 0. And then in the draw event, just for now, we're going to be saying draw text. And at X and Y, we're going to set this to 0, 0. We're going to be drawing the points. So if we run the game, we would see that there will be a big 0 in the side, as you see. Now we want these points to go up every time we pass through the pipes. So to do that, we are going to be going to the create event, or rather to the bird scripts, because we added everything here already. So when the pipe is at the same X coordinate as the bird, that's when the points will be given. So we're just going to be saying if X is equals to pipe xi, then we're just going to say PTS plus plus, as so. So if you run the game, and we are going to move, every time we pass through the pipe, the points will go up. So now we're at 1, 2, 3, 4, 5, 6, 7, 8. There we go. So we see it's working very fine, and this is basically the fundamental part of Flappy Bird. The next thing we're going to do is adding all the menus, adding all the flares, and the game juice or the game feel. Now there's still a lot more to discuss, but seeing how this video is already almost 50 minutes long, I think it's about time that we wrap things up. So thank you very much for listening all the way through this tutorial. Part 2 will be coming out soon. Don't forget to like and subscribe for more of these videos. I know I haven't been making much videos in the past year, but hopefully I will try to make more in the future. Thank you very much again, and hope to see you guys next time.